Right, so we want two different points on the line, okay? Okay, so again, it's really just like, for me at least, what I did before. For one of the points, I'm going to take x to be 0, okay? Then we want to calculate what y has to be. When x is 0, what does y have to be? Well, you're killing off this number, this part over here, because x is 0. You're left with this. And so from here, we end up with this. We have 2y over 2 is 4 over 2. So it follows from this that y has to be 2, right? Because, when you divide by 2, the 2's cancel. You get y is 2. And so this point is on the line. This point is on the line. Okay, so that's good. So when x is 0, y has to be 2. What about another point? Well, I took y to be 0, okay? From there, we can figure out what x has to be. Namely, from here, we just replace y by 0. And this part goes away. And so we get 7x is 4. 7x is 4. The 2 times 0 is 0, so that's gone. We can divide by 7. Dividing both sides by 7, that is. Right? Because we don't want 7x, we want x, so we divide, and we get x equals 4 over 7. And from there, we get this. So because of that, we have 4 over 7 comma 0, right? And so we have 2 points on the line. And so if we connect them, we can graph the line. And so we have this. So that's what we end up with. All right, that's fun. That's good. Now this is done. Okay, so we have this example done. Okay. That's it for this section. I'm not done teaching it today. So I want to start the next section now. Let me get to it. Here we go. Just get the notes up. Here we go. Here we go. All right. So this is actually section 2.4. Here we're going to see what functions are. Now, I'm not trying to scare anyone, but this is actually one of the hardest sections we cover. Functions. And so that's really it's one of the hardest ones we're going to see. I'm not saying, that anyone cannot handle it. I'm just saying, though, that's not easy. That's all. I mean, functions are very important, though. Yes, we're going to see what functions are. We're going to see how functions come about from what are called relations, correspondence mappings, equations and graphs. We'll see that's where functions come from. And with graphs, you actually need what's called the vertical line test. You might know what that is already. If you don't, that's fine. But here, functions, they actually come about in almost every math class and even maybe science classes as well. I know if you go on to pre-calc and other classes, like after that, you will study functions. So that's why it's so important I'm presenting it. Okay. I mean, in the past, when I taught this class, I taught it a little bit differently. So I found what I'm doing here, presenting what a function is by showing how it comes about through relations, correspondence mappings, and other stuff. That actually, for most people, made it a lot easier. So let me go that way. So remember, I might have said this in the course already. Remember, though, a set is nothing more than just a collection of objects. I know the book goes a lot more into set theory than I think it should. A lot more than I'm gonna ask anyone. But it's still good to know the definition of a set. I mean, it's not really, although this is not really the formal definition, but you could think of a set as just a collection of objects. You could think of a set that way. And there is some notation with sets, namely what we do when we denote what a set is we use these curly braces here, as you can see. We use these curly braces. Namely, with a set, what we do is we use the curly braces and we list the elements in the set between the curly braces separated by commas. That's actually what they call the roster form of a set. Also, we never list an element more than once. In a set, you don't have repetition when you're listing the elements. And that's just what people do in sets. They don't list an element more than once. Okay. Now, so let's now see what a function is. Well, let's suppose we have these two sets, capital X. Usually people denote a set by capital letters. You have capital X, you have capital Y. So these are two sets. By definition, a function is a rule. It assigns to each element little x from the first set. It's assigning to each element little x from the first set to exactly one element little y in the second set. So a function, little f, that's what f is here, it's a rule that assigns to each element in capital X exactly one element from capital Y. The exactly one part I actually underline because that's actually very important. Now, for us, you can really have sets of anything. For us, though, X and Y are going to be sets of numbers. They're going to be sets of numbers, okay? And really, the way you define a function is you somehow specify what that rule is. And you can use relations, you can use this kind of diagram I have here, which is actually called a correspondence diagram. I'm actually denoting what the function does using arrows. Sets, I'm denoting by these big circles. Although on some slides, it's going to look like an oval. But that's what they call a correspondence diagram. And you can actually can specify that rule using a correspondence diagram, using equation in X and Y, using a graph, using a relation. I mean, as long as you're specifying what that rule is, and that rule satisfies the conditions of the definition, then you have a function. You can think of this definition almost like as a template if you want, where to have a function, you have to fit the template, if that makes any sense. I hope it does. But anyway, here's some more terminology. The first set, capital X here, right? We call that the domain of the function. Okay, that's the domain. That's where all your x's come from. The second, what the function gives back to you is called the range. So in other words, all the elements in Y, the second set, that are assigned something from X, we call that the range. Here's actually a better way of thinking about it. I mean, I like to think of a function as like a machine, where what goes into the function is input. And the idea is your input comes from the domain. The function is some rule that does some crazy stuff in the background. And for each input, the function gives you back a unique output. The collection of all your inputs is the domain. The collection of all your outputs is the range. So everything that goes into the function is the domain. What comes out of the function is the range. And this is just saying what I said before. We can use a correspondence diagram, which looks like this. Although usually you're going to have more elements here and more arrows. So our first example, let's say X was this set. We have just 4 elements in it, 1, 2, 3, and 4. Let Y be this set, 2, 4, 6, 8. So we have 2 sets of numbers. Then we can have this correspondence diagram below, where X is assigned, 1 is assigned to 2, 2 is assigned to 4, 3 is assigned to 6, 4 is assigned to 8. Then we have a function. The arrows here you can almost think of as our machine, so to say, or the rule. The rule says that 1 is assigned to 2, 2 is assigned to 4, 3 is assigned to 6, 4 is assigned to 8. We have a function. This is our domain, all the inputs. This is the range, all the outputs. Normally in Y, you could have elements that are not outputs. That can happen. You don't have that in this case, but it could happen. The only way this would not be a function is if 1, for instance, if you had an input going to more than one output. So if 1, for instance, went to 2 and 1 was assigned to something else, then you would not have a function. We'll see that next time. We'll do more examples of this, but I have to stop now. I'm running out of time. All right. So let me just save this. So we'll stop here.